Hi everyone, welcome to Edu-Malanga. We do mathematics tutorial videos for Matric in South Africa. Today we're doing examples on the sum of arithmetic series. This is lesson 3 in the first unit of the year, which is patterns, sequences, and series. We're going to do 2 examples on the sum of arithmetic series. But before we get started on the examples, let's remind ourselves of the 2 equations that we derived in the previous video that you use when solving problems to do with the sum of arithmetic series. If these equations are confusing to you or you haven't seen them before, I suggest you watch the previous video. It's going to help you understand the equations and you'll also be able to follow the examples. The first equation that we derived looks like this: Sn, which is series or the summation of the terms of an arithmetic sequence to term number n. It's Sn now, it's no longer Tn, is equal to n over 2, open big brackets, 2a plus, open smaller brackets, n minus 1, close, times d, then you close the bigger brackets. This is the first equation that we derived. To solve this equation, you need to know n, which is the term number, a, the starting term, and d, your common difference. The second equation that we then derived looks like this: Sn is equal to n over 2, open brackets, a plus l. L is a new variable and it stands for the last term. So to use this equation, you need to know the last term of an arithmetic series. Now that we've reminded ourselves of the equations, let's get into our examples. The first example we're going to solve, example 1, the question looks like this. Find the sum of the first 32 terms of this arithmetic series, because we're looking at arithmetic series. And the arithmetic series goes like this: 4 plus 11 plus 18 plus 25 plus 32, and it keeps on going. So to solve this question, the first thing we're going to do is list all of the things that we've been given. Let's do this on the next page. The first thing we've been given is 32 terms, so that's equal to n. We're summing n terms, which is 32 terms. N is equal to 32. The second thing we're given, we can read it from the arithmetic series as is presented, is a, which is 4. A is equal to 4. And because we can see the arithmetic series, we can very easily solve for d, which is the common difference. We're going to use 11 and 4, term 2 and term 1. And so our d is going to equal to term 2 minus term 1, which is equal to 11 minus 4, and that's equal to 7. We now have n, a, and d. These are the things that we're given or that we can very quickly measure and find from the question. Let's come back to our 2 equations. The first equation requires you to have n, a, and d. And this one requires n, a, and l. We don't have l, so the first equation is actually the one to use to solve this question. So let's get started solving. We'll start by rewriting the equation. Sn is equal to n over 2, open big brackets, 2a plus, open smaller brackets, n minus 1, close, times d, and you can close the big brackets. We're going to substitute in everything that we have been given in the question, and then we'll solve to find what Sn is. Sn becomes 32, so we have S32 should equal to, again, 32 over 2, open the bigger brackets, 2 times 4, that's our A, plus our N is again 32, 32 minus 1, and our common difference we calculated as 7, and we can close the brackets. We just have to solve this equation and we'll know what the sum of the first 32 terms of the arithmetic series is. Let's start by simplifying what's in the big brackets. 2 times 4, that will be 8. There's a plus sign, so that separates. 32 minus 1 will become 31. Oh, and 32 can be divided by 2 as well. 32 divided by 2 is 16. So you have S 32 is equal to 16, open brackets. 2 times 4, we said that is 8, plus 32 minus 1, that's equal to 31, times 7, can close our brackets. Okay, let's continue on the next page. We'll multiply 31 times 7, so this will become S32 is equal to 16, open brackets, 8, plus, use your calculator to solve this, 31 times 7 is equal to 217. We close our brackets, and now we just simply have to sum what's in these brackets. So S32 is going to equal to 16 times 8 plus 217 is equal to 225. And if you put this into your calculator, you'll find that S32 is equal to 3,600. We've now solved the first example on the sum of arithmetic series, which asks us to find the sum of the first 32 terms. Let's move on now and do example 2. The question that we're going to solve in example 2 is, what is the sum of this arithmetic series? Very short question, easy looking, right guys? Let's get into it. The arithmetic series looks like this. You have 7 plus 13 plus 19 plus 25, and it keeps on going, plus 115. We'll again start our solution to this question by listing the things that we've been given. We don't have n this time, okay, we can't see it, but we have a, we have the last term, and we can find the common difference. So let's do that. A is equal to 7. Our last term L is equal to 115. And if we look at 13 and 7, for example, term 2 and term 1, we can say D is equal to term 2 minus term 1, which is equal to 13 minus 7, and that gives you the number 6. Let's go back to our two equations. We have equation 1, which requires A, N, and D. We don't have N. Equation 2 requires N, A, and L. We have A and L and D, but we don't have N, so we're going to have to find a way to solve for N. Let's start by rewriting the second equation. Sn is equal to N over 2, open brackets, A plus L. Close our brackets. We're first going to have to solve for n, and how we do this is by using the last term which is given to us in the question. We're going to use the general term of an arithmetic sequence, substitute in the last term, and solve for n. Let's go. The general term of an arithmetic sequence looks like this. Tn is equal to A plus, open brackets, n minus 1, close the brackets, times d. This is the general term. We know what Tn is because we know what the last term is. We know what A is and we know what D is. So we can solve for n then. Tn, let's substitute. 115 is equal to, let's remind ourselves, A was 7, D was 6. Let's substitute. A is 7 plus, open brackets, n minus 1 times 6. Okay, we're solving for n, so we'll start off by removing 7. So we do this by subtraction, minus 7. And what we do on this side of the equation, we have to do on this side as well. So we get minus 7 here as well. The 7s will cancel out on this side of the equation. We'll have 115 minus 7. That's equal to 108 is equal to, open brackets, n minus 1 times 6. We'll then divide by 6 on both sides. Divided by 6. We'll also divide by 6 on this side. The 6's will cancel out on this side. We're going to have 108 divided by 6. That's equal to 18, which then is equal to n minus 1. Again, we're solving for n. Let's get rid of minus 1. We'll do that by adding 1 on this side of the equation. And we'll add 1 on this side of the equation as well. The 1's are going to cancel out on this side. And then you get, therefore, 19 is equal to n. We've now solved for n. We have everything we need now to solve using this equation, the sum of the arithmetic series. Let's get started. We'll rewrite the equation. Sn is equal to n over 2, open brackets, a plus l, close. Let's substitute in. We have s to 19, because our n we solve for as 19, will be 19 over 2, open brackets. Let's remind ourselves, a is 7 and l is 115. So we have 7 plus 115, close our brackets. 7 plus 115 is equal to 122. So S19 is equal to 19 over 2 times 122. 122 can be divided by 2. When we say 122 divided by 2, the 122 is going to change and become the answer, which is 61. And the 2 is going to be cancelled out. So S to 19 becomes 19 times 61. And if you use your calculator and calculate 19 times 61, you'll find the answer is equal to 1,159. And that is equal to the sum of the arithmetic series we were given in example 2. We've reached the end of the example video. I hope you were able to follow the examples and that you understood what we were doing. Join us again in the next video. We're going to do more examples on the sum of arithmetic series that are more complicated than the 2 we've done today.